All attendees are in listen-only mode.
Start.
Okay. I wanted to first of all thank everyone for spending their very valuable time attending this presentation on a subject that I'm fascinated with and I have studied a lot. And my hope is that you will leave this session. Of course, you'll have a lot more questions, but you'll have a foundation of understanding that will allow you to evaluate if table partitioning would make sense in your environment. So let's go to the beginning. Hopefully everyone can see my screen. So we're going to start at the beginning. This is not an advanced session. It assumes, of course, you know something about databases and tables. I've been a DBA. I'm going to give away my age here. Been a DBA for a very long time, and I'm known as a specialist or someone very knowledgeable about in-memory OLTP, which I've blogged very, very extensively about on my website. But I also am interested in other things like PMAN and table partitioning. I may not blog about all of them, but I have a lot of fascinations in SQL Server, currently always encrypted. I think that's my most recent blog post. But anyway, I dive as deep as I can and try and save other people from spinning their wheels. Okay, that's a bit about it. Today's agenda is to discuss these three things: the intended design goals of table partitioning, what data movement is. I will refer to it several times before I explain what it is, so we'll get to that, but it's critical that you understand that, and what the potential use cases are for table partitioning. When we say goodnight to each other, you will hopefully have an understanding of the architecture, the benefits, and the potential issues. I like to say, and I believe it's true, that even the gotchas for table partitioning have their own gotchas. It's kind of like that. There are multiple things that can be partitioned. One of them is views, which we're not going to get into today, just not enough time. And the other is tables and indexes. The same concept applies to both tables and indexes. All tables are partitioned, and I'm going to prove it to you now. I'm going to jump out to SSMS and go to my all tables are partitioned script. And we're going to go here. Hopefully everybody can see my screen. We're just going to create a temp table. And then we're going to go to tempdb, and we're going to select data from sys partitions where it matches our table name. And we can see, we have a couple of things here. This table that we just created is this one, and it has a partition number. Of course, the partitioning feature is not able to be used with this table because we've not done all the other prerequisites. But internally, it does have a partition number, which means that all tables in every edition have some concept of partitioning. Whether or not you can use that is another story. Now, table partitioning used to be an enterprise-only feature. Now it's available in all features, all editions, I believe, but requires other things in order for you to use it. So anyway, just a brief demo that all tables are partitioned. You get to choose one partitioning column or one partitioning expression, which appears as a column and it must be persisted. It's possible to create columns that are not persisted. I don't believe those could be indexed. So basically, you need to have all types of internal structures that reference the partitioning column, and it must be something that the engine can grab onto. So that's a computed column that's persisted or a regular column in a table. Indexable data types are supported only for the partitioning column. So you're not going to, just to be clear, you're not going to create a full text index on some columns, on a column of text data and a partition of that. That's not going to fly. Strings, integers, etc. I have a question for the attendees. You can plug your message, your response in the chat, or open your mic. I'm wondering what people think is the intended design goal of the table partitioning feature, whether whether it's for performance or administration. I think I got muted there. If no one chimes in, I will eventually respond, but I'm just wondering if anyone has an opinion.
Yeah, if you could repeat it, it did mistakenly get muted. So
No problem. So, Adam, what do you think?
I didn't hear the
Performance?
question. It was muted.
Question is, sorry, do you think the intended design goal, this is a question for everybody, but anyone can answer. What is the intended design goal of the table partitioning feature? Is it for enhancing performance? Is it for making administration easier? Is it for both?
I would probably say for both, just because it probably, there's a few features that have one singular purpose when it comes to SQL Server.
Okay. All right. Well, we're going to go over the approaches to either, to both rather. So if your application has lock escalation that eventually reaches the table level because it just grabs too many locks, and SQL Server then escalates it, I think it defaults to 5,000 page locks, at which point it escalates to a table level lock because it's just too much overhead to actually track all of those page level locks. If that was a situation you were encountering, then table partitioning could be, it's tough to say it's a performance benefit, but you can escalate only to the partition level. Then again, all your activity may be in the current partition, so that won't really help you. You're still locked. So it's a maybe, but lock escalation is able to be escalated to a level other than the table level. Can go to partition level. If you have your data spread across multiple drives, which you should have anyway, depending on what your backend looks like, you may see some performance increase, but this probably was a concept from the days of spinning drives. I don't know if this would apply to SSDs. The documentation says you can partition for joins. I'm not positive that's viable today. Again, the feature is older. It hasn't been updated in a while, and I'm not sure the documentation has been updated recently. Partition elimination. Everybody talks about this. Okay, I'm gonna partition my data. I'm gonna get partition elimination, which means you can filter your data just on some subset of what you're looking for, and boom. Well, what's the difference between that and getting a seek from a clustered index, or a non-clustered index if in the specific order? So partition elimination sounds great, but the equivalent is doing something other than a table scan for a non-clustered or a clustered index. So partition elimination is what you desperately want if you do partition, but I would find it hard to believe that that in and of itself would beat a seek for an index. For administration, we have something called switch in and switch out, which we'll be explaining later. It's a way to move data in and out in a metadata only fashion. So you can put a bunch of data in a staging table and just switch it in, or get rid of the whole partition's worth of data, billions of rows, just switch it out to some other table and do something like that. That's the basic definition of switch. And it does have some minimal logging associated with it, but it is nothing related to the full data set. You can have different levels of compression per partition. That would include none, row, page. Once you get to column store, that's table level. So if a table's partitioned, then you use column store, then your column store index is compressing everything on all partitions. So that's a slight curve there. But anyway, there are options with compression if you partition. Maintenance, as in index maintenance, truncating tables, this can be a huge administrative plus. Because if you have gigantic tables, doing index maintenance on the entire table when most of it is, the data is static, would not seem to make a lot of sense. And if you need to remove tons of data from in this case, a partition, you can do that as opposed to the whole table. You can update statistics per partition. It is not what the holy grail that people wish it was. But yeah, you don't have to scan all the data in your entire table in order to update stats. theoretically. That's why there's an asterisk. You can back up and restore at the file group level, assuming you created file groups and split your data amongst different file groups, which is kind of at the core of table partitioning. We'll be discussing that in detail shortly. So in my opinion, and these slides seem to bear that out, it's really more of an administrative feature. It's not designed for performance. It's designed to ease the pain of wielding huge data sets. And by the way, it was designed way before you had anything like the volume you have today. You can have, as of 2008 and later, up to 15,000 partitions. If you get anywhere close to that, you'll probably regret never having been born, but it's possible. Potential issues with partitioning. Well, it's a complex feature, as you will discover today. The number of people that really know it well enough to make intelligent decisions about it is few. So if you hire a consultant to come in and figure it out for you, and it's a go, you decide to adopt it, and then they leave, you'll kind of be stuck not really understanding how to modify it or maintain it for the future. So you need someone in-house who really understands the feature. Data movement, this will be in red letters later. We'll discuss what this is. You want to desperately avoid data movement when doing things with partitions. Predicate changes. So if today, let's say you use entity framework, you don't use any stored procedures, your UI generates SQL that is sent to the engine, and it's not easy for you to change that SQL. Well, if you change the way your data is physically structured and stored by partitioning it, you may have to change a whole lot of queries, and that may not be possible, because if the query does not reference the partitioning column to filter it to get partition elimination, you will do a table scan. That is likely to cause you to not adopt the feature. So the ability to adopt the feature depends on how you do your queries. Okay, maybe UI stuff is okay, not really doing big data, right? But maybe reporting would have to change if you're not always already using stored procedures, which would be easy to modify. But again, maybe you have 10,000 procs, and it's still not easy to modify. Or it could be that you're already clustered on the column that you would also be partitioning on, so all of your queries are already in good shape. Like, it's a huge, it depends, but it's a potential issue. Your partitioning column must be part of the primary key, which means if you have foreign keys, they must include that as well. So you're going to have compound column, multi-column foreign keys, referring back to a multi-column primary key. Unique indexes must also include the partitioning key. This, for large tables, which is the only reason you would probably be interested in the table partitioning feature, this can cause have a huge effect on storage, because even adding a single 8-byte column with billions of rows, it adds up, as I just said. So not just for those indexes, PK, FK, and unique, but also other storage for indexes. Let's start from the foundation. You have to have a file group. Well, in SQL Server, you have a default file group that your data file is part of when you create a database. It's the primary file group, it's the default. So to adopt table partitioning, you probably want to create an additional file group or multiple other file groups, but let's keep it simple. You have a file group. You have something called a partition function, which basically tells SQL Server how to separate your data. It's not anything about how to physically lay it out on disk. It's just saying, logically, these are my boundary points. I'm going to go from this date to that date, and then from that date to the next date, or however you're partitioning. So you're defining the boundaries. That's all it is a logical definition for how you're breaking the data apart. Then you have something called a partition scheme. And the partition scheme must reference the function, which is why you create the function first. And the partition scheme tells SQL Server how to map those boundary points to file groups on storage. So you create a table on a partition scheme, which references a partition function, and ultimately that maps to a file group. This is the basic concept. remember one question I had in some test certification I took long ago was, which do you create first, the scheme or the function? And I honestly couldn't remember, so I guessed. But this should let you know it's clear. I have numbers next to it. You got to create the function first. You can have different partition functions and schemes in the same database. You can have many tables associated with the same scheme and function, or you can have different sets of tables associated with different schemes and functions. It's up to you. It's just more to maintain if you break it up. So this graphic looks kind of simple, but it's as complicated as I guess you need it to be, but it's flexible. Excuse me, just taking a sip of water. Let's look at the syntax for creating a partition function. It needs a name, which you have, obviously over here, the PF sum table. It needs a data type. And then there's some other syntax which we won't go into yet, and you give a list of values. And this is a really simple example of creating a partition function on a single value, which means you're going to say anything that is January 1st, 2013 and greater goes into some bucket, and everything else that's before that goes into a different bucket. That's essentially what this partition function would do. Then you have the scheme. So you see the scheme in red, it references the partition function. And you would have already created file groups. And in this case, you're going to, let's say we call it FG_2013. What you defined here on the left is going to map to this specific file group for values greater than or equal to the boundary point. So you need another place to put data that is below or outside the expected value. So we're defining an explicit boundary point, but implicit is that things that are lower than that boundary point go somewhere else. And this is why the syntax looks a little different between the scheme and the function. You're always gonna, it's n+1. You're gonna have whatever number of file groups you're explicitly splitting your boundary points to, and then you're gonna have one more or two more, depending on whether you wanna just have data that goes anything above what you defined or anything above and below what you defined. So you need to map it out in an Excel, on a whiteboard. You need to figure out how you're gonna break your data up, and then how you're gonna create your file groups, and what's going to happen to data that goes above or below your expected range. Our mission, we're going to do this now, is to create yearly partitioning for 2012, 2013, 2014, because there's nothing like experience, right? Our partition function will look like this, as range right for values, and we have January, let's go back one second, 2012, 2013, 2014, right? You'll notice here that I have also 2015. That is to hold data that is beyond the expected values. We expect from January 1st, 2012 to December 31st, 2014. And if somebody inserts data that is above that, or outside that range, we don't want it to fail. We want it to go into this last bucket here. Okay, so partition 1 would be January 1st, 2012. And then partition 2 is January 1st, 2013. I put them vertical like this. There's a lot of visuals here. Put them vertical like this so you can kind of clearly see what's in purple is what you explicitly defined. But within that definition, there is an implied upper boundary for the partition. So if you say P1 starts at January 1st, 2012, and P2 starts at January 1st, 2013, then you're saying that the maximum value that can go into the P1, partition 1, is December 31st, 2012. That's how it works. So you don't define every value, you just define points that allow the engine to slice and dice your data. So just to see it through further, the explicit and implicit values would look like this. So this defines partition 1, partition 2, partition 3, and then anything that's above that December 31st value, we want to go into this file group, the 2015 file group. That would be, let's say, partition 4. So that's how this partition function would be kind of logically associated with ranges of data. And I just want to ask the attendees at this point if there are any questions about what we've covered so far, because this is the kind of critical, fundamental stuff to make sure you understand. It's
So if you
quiet
were to
there.
add another partition,
Sorry?
if you were to add another partition, you would just run this create function again and add like a 2016.
Correct. Well, no. There's a, okay, I'm gonna retract my first yes. I'm gonna say no. If you need to, so right now, let me ask you a logical question. This partition function is based on date, right? Because the data type is date. So what's the max value that you can have in a date data type? It's probably like December 31st, 99.99, right? So if you want to say now I need to go from 2016, like my expected range includes 2015, but I need to go to 2016, you need to split that last partition. So you would use the split syntax of partitioning. You would not recreate the partition function. It won't let you do that probably. There's no need to do that. You would just modify what's there by using split. And we're going to get into split later. So if you had a sliding window scenario where you want to drop the lowest value partition and add a new set of ranges for your next year, you're doing split and merge. We'll get into what happens with those a little later. But yeah, in the background, they may modify the partition function, but you don't modify the partition function yourself, unless you're starting from scratch all over again. Is that clear?
Yeah, thank you.
Sure. So this is kind of initial setup, and then there's maintenance, and we'll talk about that. And if I just want to say that if there's anything that I don't cover today, or that you're not clear about what we covered, my contact info will be available at the end. You can always write to me, and I will do my best to explain it to you. So again, this is initial setup, and this is what happens with the values that you explicitly state and the others that you don't explicitly state. Expected range, greater than expected. And I'm going to hammer this a million times because it's not intuitive, the syntax, in some ways, because you'd expect like, hey, I'm creating a partition from a 2015 data. No, you're creating a partition for anything that is January 1st, 2015 and above, up to the max value for the data type that you're partitioned on. That's how to think about it. Okay, range right. I want to get it because there's also a range left. I want to determine, clarify what that means. So we discussed that, this is from the earlier slide, it's just a bigger version of it, that you're going to define these boundary points, and there's other implicit maximum values for a partition that are generated when you define these boundary points. So I'm going to swing these tails. See, like this tail is going to the right. Yeah. There's different ways to think of this. The way that's clearest to me is that when you use a range right partition function, you are defining the minimum value for that partition. That makes sense to me. I don't know why they called it right. Maybe because they're saying you are defining the value that is on the right side of whatever boundary point is split there, like here, between, if I can get my mouse here, like here, you're in between two partitions, right? And you're defining a boundary value that's on the right side. Maybe that's why they thought of it like that. But for me, it's simpler just to remember that you're only defining in range right the minimum value for that partition. So this is the way it kind of looks for range right. We'll get into how you can do this wrong and what it means in a moment. So best practice for partitioning in general, whether you're going range right, range left, doesn't matter, is to keep an empty partition below and an empty partition above for data that falls outside the expected range of data. This is the right way to do partitioning, and you will see why in a couple of slides. But I want you to kind of, if you review this recording, I want you to take a snapshot or a screenshot of this image, because conceptually, this is what you need to do for all partitioning. If you want an insert to fail, then you would leave it. I can't do it because I don't have it there. So you want an insert to fail, then you wouldn't have these outside file groups, right? Most people don't want their application to fail if an insert is not kosher, shall we say. And again, these things map to a file group, and a file group has at least one or more files. So another way, just to be clear, another way you could have things fail, you still could have a file group defined, but don't have any files defined for that file group, and the insert will fail. If you wanted that as like a, I don't know what, maybe some error handling catch-all, something like that. But normally you will want it to look like this. Each file group, each partition has its expected range of data that goes to a specific file group, which has one or more files. Just to keep it simple, I have only a single file for each file group. So 2011, which is here in the lower left, this box, through 2015, those are logical boundaries for data. They're also names of file groups if you want them to be. I find that file FG1 and FG2 doesn't make a lot of sense when you look at it in a database, and files that are named generically don't tell you what it belongs to. So if possible, I like to be explicit. So this is what we're trying to do, yeah? And this is the difference between range left and range right. In range left, you define the upper value for the partition. In range right, you define the lower value. This slide should make it clear. They both do the same thing, but they go about it differently. But there is a subtle difference for temporal data, for date and date time data, that is a huge gotcha, which will cause you all kinds of problems down the road. But conceptually, let's just say you wanted to use range left and you wanted to have up to this number go in some partition. So let's say your first partition boundary is 10. So from negative whatever the data type supports up to the and including the value 10, it's going to go in partition 1. And from 11 to, let's say, 20 is the next point, it's going to go into partition 2. That would be a way to do it, to kind of limit it and define the upper boundary. That's great for integers. That is not great for data, for date and date time data. Because the time tick value of each of those data types changes depending on the data type. And you will see in a moment what this means. This is the way you would define the same logical breaking up of data for range left. You're defining again. Notice how originally I had in red 2015 and greater. Now I have in red 2011 and less. Yeah, because you're saying you're limiting the value that the data can go up to. You're defining the maximum value for that partition with range left. So this is what it looks like for range right. This is what it looks like for range left. And a subtle difference would be on the right side for range right, we're saying greater than or equal 2015. For range left, we're saying up to and including 12/31/99, because that's the max value for a date data type. A critical but subtle difference. Now, if we define, you should see clearly from this slide that we are defining range left, because those tails here, I can't really move my mouse too well, right here are swinging left, right? So we're saying we're defining the upper boundary for a partition. We're saying, incorrectly, we're saying it's the lower value it's the beginning value of a year. So that means that you have multiple years, even though it might only include one day for the 2013. In the same partition, you have a full range of data for an entire year, 2012, plus the first day of 2013. And all the rest of the days for 2013 go into this partition. That makes no sense logically. If you want to remove a year's worth of data, you can't. You can remove 364 days worth of data at a time and then have to go manually delete that January 1st date. This makes no sense. And I see this in the field. I see it at my current job. Someone did not know what they were doing with partitioning, didn't understand range left, and they defined lower boundary points for range left. And it just it can only make your life miserable. So I will hammer this into you folks ad infinitum. This is the wrong way to do it. But there's nothing that visually tells you this in SQL Server. It is happy to let you do it wrong. You need have a script that I can send to Adam that he can send to others. I have a script that tells you for each partition what the boundary points are, and you need some kind of validation like that to just triple check that you did it correctly. Data types matter for left, right. So there's no difference between date time here that we're using, and we're specifying zeros for the time tick value, and not specifying values for the time tick value. There's no difference. Internally, it will be stored according to the data type, which is date time. So internally, it will be represented like this, even if you only specify that, which it lets you do. But for range left, you must specify the maximum value for the data type. And for date time, that's not 2359, 59, 59. It's 997 at the end. You would have to know that. And if you did it wrong, then some rows would go into the wrong partition. And this is why it makes no sense. No one can ever convince me otherwise that range left is correct for date-based data. So if you're using temporal type data, you want to go range right and specify lower boundaries, and you never have to be bothered with explicitly expressing the values for the upper bound. People understand this? I hope. I'm moving kind of quickly, and I'm repeating myself often, which I don't like to do, but it's critical that folks understand this, because these are the beginner's mistakes that people make, that 3 DBAs from now, when you come on to the team, you will inherit something like this. There are ways to fix it, but not without pain.
No, I think the information you're giving is really great. I'm currently in a project right now that has been going way longer than it probably should have, because I've had to rewrite tables multiple times because I've messed up my partition functions. So I kind of wish that I had this last year. It is great information.
Well, Adam did invite me, but it would have required me getting on a plane then, so I couldn't do that.
Right.
So I'm very sorry about the delay.
Oh, that's okay. But how I kind of, like, the best way for me to remember range left and range right was to literally draw out a timeline and to like mark it off, and anything that was to the left of me was my range left. And so that was, I'm a very visual person, so that's how I ended up figuring out. But I did have to rewrite my tables a couple different times before I could move forward with my project.
I honestly struggled with how to impart this kind of knowledge across a presentation, and so I just tried to do it like 3 or 4 or 5 different ways visually, which is what I have in this presentation, because hoping that somebody will latch onto one of them. I'm not that visual. I'm more kind of logical and auditory, but however you need to do it for yourself, that's the way you got to do it. And you may inherit someone else's way, which doesn't work for you. Make it so that you know what to do and you understand it. And you'll probably leave it better for those who come after you. Another thing, which I'll mention later as well, is that when making changes to tables that are partitioned, you cannot, nobody will do this in the right mind anyway, you cannot put it in production to begin with, of course, but even if you put it in dev to begin with, you need somewhere you can test it. If that's your workstation or your laptop or whatever, you need somewhere you can vet with this other view that I will share with you, that what you want to do is correct and that there will be no data movement. Because if you do partitioning wrong for data that you're currently partitioning, well, data has to move when you go from non-partition to partition. That data has to move around, and you're going to have a lot of logging. But later, when you've got, let's say there's a new table, right? But they're expecting 25 billion rows, and they partition it from the beginning. And in the beginning, you'll have no pain from partitioning it because it's got no data. Then later, or whoever comes after you will be cursing you, then things need to change. And if you didn't do it right, there will be data movement of billions and billions of rows, and there's no way around that, depending on the exact situation. So what you want to do is go to some safe sandbox environment, use this view I can share with you or something like it, and see literally how many rows move around from partition X to partition Y. And you won't feel any pain because you probably have very few rows in dev or on your laptop. But you got to look at the numbers, because if that one becomes 1 billion, yeah, you're going to feel it. And the logging for data movement is up to 4 times regular logging, because it has to be deleted from partition source. That's fully logged. Has to be inserted into partition destination. That's fully logged. But there's other housekeeping. It's not regular logging. It is nightmare logging. Hopefully that no one ever runs into that. So range right equals lower boundary point. I have them in red. Range left equals upper boundary point. I have them in red. So you could do the shock and awe, look at the screen 100 times. Anyway, this is how I remember things. Let's see. A partition scheme maps boundary points through file groups to storage. So we talked about the boundary points and all that, but just want to be clear that on the left here we have what's in blue here is the concept. Sorry, let me say it again. Our partition scheme is the concept of taking the boundary points and file groups and putting them onto storage. Just want to be clear about that. Let's talk about switch. Switch, as I mentioned before, allows you to move data in and out of a partition table with metadata only. You would create a staging table. You would switch whatever partition from your source table you want to be switched out. You would switch that out to the staging table and then truncate the staging table. And voila, you have almost no logging. And that doesn't matter if there's 50 billion rows or 50 rows. There's a little housekeeping that has to be done, but that's the general concept of switching data out. Because after all, if you're partitioning data, it's probably big data and you have to do something with that data down the road, like archive it or just change the retention of it, etc. Now, there are requirements for switch out. Both the staging and the source must be on the same file group. The DDL must match exactly. You cannot have any foreign keys reference the table that is going to have a partition switched out, which means to me, this is really not ready for an OLTP environment. This is for data warehouses, because OLTP has usually tons of FKs. You could drop the FKs, switch out, and then recreate the FKs, but if you had the outage to do that on the weekends, that's likely to take a while with really large tables. It's mostly reading, but still. So you cannot have the source table be referenced. And your indexes must be aligned, and that means that the index must be partitioned. All indexes for the source table must be partitioned the exact same way that the table is partitioned. You could have a separate partition function and create indexes on that partition function to a different set of file groups, if that's the way you wanted to do it. But if you do that, it's not going to be aligned with the data, and you can't switch out unless you drop the indexes, switch out, recreate them, and that you definitely don't want to do. So you need alignment for indexes, no FKs, DDL match, and it has to be the same file group. There's other things that prevent switch out, but this is the core. And this doesn't matter what other features you have or don't have installed with SQL Server, this must be true, okay? Oh, of course, destination must be empty. Change tracking doesn't work. I know full text search, the indexes don't work. So yeah, you have a few things that are feature dependent, but these 4 are always, and the last one, change tracking, is maybe if you use that. The alternative in 2016 and later to switching out and to a staging table and then truncating the staging table is now you can truncate a specific partition. The syntax here references a number. I think that is extremely dangerous. I would never do that. Really easy to get it wrong. I would do a select from some internal tables and determine which partition number I needed to truncate based on a value. And then I would use that variable, defined value for that variable in the truncate statement. I would never use a literal or a hard-coded number. So this saves you some pain from having to make sure the DDL matches and all that, but it doesn't, you still need to switch out, right? And your indexes still need to be aligned. And and your table still can't have foreign keys. So this doesn't save you all the pain, it just saves you some of the pain. Column store does complicate partitioning. It does work with it, but it makes the best practice of having an empty file group on either side. It's still valid, but you have to do other things. There's a guy who was named Dmitry Korakovich, and he's a he's a partitioning guru. And I've since become friends with him. I asked him if he had ever dealt with column store and partitioning and knew about this one gotcha, and he said no. Then he wrote 2 blog posts about it, and he went into nuances of what has to happen. So it does have a few twists and turns. It's compatible, but so you just have to make sure that the features you use in your shop are compatible with replication. Sorry, are compatible with partitioning, like replication and column store. Unsupported features. Well, full text indexes, as I mentioned, are not supported for switch, but otherwise are supported. But in-memory OLTP, you cannot partition in-memory OLTP data that is stored on disk, which is data that you care about. So you have to make sure that the features that you want to use could take advantage of table partitioning. And these are just 2 examples of some nuances or, in fact, unsupportability with other SQL Server features. Potential issues. Now, I wrote here index build. What that means is if you rebuild an index on a partition table in the old days before SQL 2012, the stats were updated based on a full scan of the table. That is no longer true. It does a sampled percentage. So it could be the case that you did an index rebuild because it was timed, you were fragmented, and now, unless you specify that it needs to be full scan, you're not going to get full scan. And maybe you had full scan before, and it's going to change that to sampled. Now you have different ways of doing that with persist. There's ways to persist sampled stats percentage, but it depends on the version of SQL Server you're running. So that could be a gotcha. As I mentioned before, 15,000 partitions are supported, but you'll need enough resources to come anywhere close to that. A single table that is partitioned into even 15,000 partitions still has only a single histogram that has only 200 steps to describe the distribution of data. And this is one of the Achilles heels with table partitioning. As you add more and more data, the histogram is, I would say, more and more meaningless. It can get fuzzy, right? Because the chances of you hitting data on a point in the histogram are slimmer and slimmer. So it does some guessing. And like, even if the table wasn't partitioned, it's still going to do some guessing. And that's a lot of data to be mathematically correct about in all situations. This is one of the gotchas for table partitioning, or maybe for large tables in general, right? This histogram has only 200 steps to describe the distributed data. And data movement, which I now have in blood red, which we'll be just talking about momentarily. Dimitri lent me this slide. He said I could use it in my presentation. If you add a single 8-byte date type column, or you cluster on that and you partition on that, this is what happens to your data growth. And because of course, large tables that you're partitioning probably have a lot of insert activity, unless you just have to store 50 million, or 7 years of data or whatever. So millions of rows every day, or hundreds of millions of rows daily, means you will have tons and tons of index growth. And not everybody can handle that. And even if you use compression, you're still going to have tons of growth. So just want to be clear, this could be an issue. Let's talk about data movement. Split processing. This is going to be for range write. This should look familiar to everyone. Pardon me 1 second to take a sip of water. To the question that was asked before, how do you add a new boundary point after you already partitioned your data? You're going to do an alter partition function, and you're going to do a split based on the range of some value you give. You're going to give a data point. You're going to say, okay, I want to start a new partition here at January 1st, 2016. People can see that hopefully in the upper right here. That means a certain sequence of steps will occur. And remember, what's in blue here, the background blue, is supposed to be empty. You could have some data in there if you have a lot of data in there, and maybe you should have queries that test if you have a lot of data in there. If you have a lot of data in there, then something's wrong. You probably should split that out to another boundary point to make a new partition, not just a catch-all partition, because otherwise, well, you'll see. So actually, I can't see what this says. I have to move this screen here. Okay, the first thing we're going to do is identify which partition includes our boundary point. We're going to add that to the function. That's done in the background. So the question that was asked before is, do you modify the function? You don't, but it gets modified. Next step is to create the new partition. It does that, assuming that you've already created a file group that has a file. It's going to work. And then anything, let's see, I'm going to move this over here. 1 second. Move this to the right, to the left. So any rows that are greater than or equal to the value you specified will get moved from the formerly maximum partition. Let me go back here. All right. Let's say you had data in this 2015 partition for 2016 and beyond. And you had 50 billion rows. So we're going to go through these steps. And now all of the data that's in that 2015 catch-all partition that's greater than or equal to 2016 is going to get moved. And this is where you have that up to 4x logging because of data movement. This is exactly what you want to avoid. The way you avoid that is by occasionally polling your supposedly empty partitions and making sure they're empty. If you run into a situation like this, and you inherit a situation like this, there may be some ways around the horrible logging that will occur. You could BCP out data, but then you'd have to remove it from that partition, the catch-all partition, and that can only happen with a delete. And unless you're deleting everything, in which case you could truncate that partition, and then you could BCP into the correct partition. But that's not going to be that's going to be minimal logging. It's not going to be anything like metadata only, which is what you would get if you had properly, or if they had properly partitioned the data. So data movement occurs as a last step for range right when you split a partition. We split 2015 and greater to be 2015 through the end of the year, and now we're going from 2016 and greater. This is part of what you can see in a sliding window scenario. There's supposed to be no or very few rows associated with that red arrow here, right here. So if that's not the case, you will have data movement and you will not like it. I have to move my window around a little bit. Okay, the opposite of split is merge. Merge is a way to get rid of a partition. It's alter partition function, just like the other syntax. Merge range, and then some boundary points. You're telling SQL Server, get rid of the data that is in the partition where this boundary point exists. What does it do first? It identifies the boundary, the partition, in this case, partition 1. It then moves the rows because it has to move them immediately, not last, like range right. So it's going to move any rows that are in here to the catch-all partition file group that defines things that are below 2012, right? Now it's going to be below 2013. It removes the boundary point from the function internally. You don't have to do that. And then logically, it kind of looks like that. And then it removes that from the partition scheme. So it does do some housekeeping for you. But again, you will have data movement unless you were sure. Well, let's say you could have done these steps without switching out and then truncating. If you just try to remove a boundary point without doing that, you will definitely have data movement if you have data in there. You need to switch out first, then truncate, and then remove your boundary point. That's the way to do it. Okay, let's go to the real world. I'm going to create a partition test database. This is just my laptop. Oh, wow, hey. Maybe I know what I did. I cleaned up before. Bear with me a moment. Okay. We're going to create this database. Nothing to it, 10 megabytes, single file. I should say before I go on, do people have questions? Because you're going to basically watch me do what we just explained logically, but I wanted to explain it to you visually first. No questions? Must be an awesome presenter. Okay. So we're going to create this view, which lets us know how our partition boundaries look. This is like a helper view based on many others that I perused on the internet. We're going to add a file group first, the FG other that we saw earlier in our presentation. We're going to add a file to our file group, FG other. We're going to add a file group for 2013 and then add a file to that file group. Creating the function, which is just what we had in the presentation, just a single boundary point based on date, time, data. Then we're going to create the partition scheme. And I have notes here which says, remember, we have to have n+1 references in the partition scheme where n represents the number of boundary points as described in the partition function. So our partition scheme is going to reference the partition function and both file groups, FG other and FG 2013, and our explicitly defined boundary point data that it matches and or is greater than that boundary point will be in this file group, and all other data will be in that file group as a result, if we did it right. We're going to drop the table if it exists. We're creating a table on the partition scheme, and we're going to define the column that we're partitioning on, and we're creating a table as a primary key constraint that includes our identity column, and it must include the partitioning column. And this is the way that your indexes get bloated from partitioning. Imagine you had billions of rows in this table, and other tables that have to reference this have to reference these two columns, not just the PK. So we're going to do this. This is what actually partitions existing data. So you would have some movement as a result of that initially. Let's look at our view, right? We're going to see, okay, we have two partitions, and it should tell us, I have to move some stuff around my screen. It should tell us on the, all the way on the right side how many rows in each partition, which is what we want to see, it's critical information, and what the partition range is for each partition. Remember that the first one, FG other, is to catch anything that's below our expected boundary point, which is greater than or equal to infinity, and modified on less than January 1st, because January 1st goes here, goes in 2013, goes in the 2013 partition. This looks correct. But you want to use this helper function view or something like it to make sure that you did your boundary points correctly and that they are correctly mapped to the proper file groups. Without doing something like this, your strategy is hope, and no DBA wants to be having hope as their strategy. Okay, so that's why this view or something like it is so helpful. We're going to insert some rows. And now we're going to check the view again. So what did we insert? We inserted one row for 2012 and all the rest were 2013, January 1st or beyond. So we would expect to see 3 rows in the FG 2013 group, partition rather, and 1 row there. That's what I would expect to see. So we will, that's what we see, right? We see 3 rows there and 1 row there. So, of course, the script is, so I've been through this a million times. I know the script is correct. Now let's add other file groups and other files to those file groups. We're going to drop our table. We're going to drop the partition function. We're going to drop the partition scheme so that we can create the table again. Let's split the data around. So this, in relation to the questions the person asked before, I am doing the brute force redo here. That's because I got 4 rows in my table. So now we'll create our table on the same partition scheme, and we're going to see what it looks like. Now we have multiple partitions with different boundaries that connect to different file groups. This is probably a more real-world scenario where you would see something like this as opposed to a demo with a single boundary point. Of course, your environment may have many more boundary points. So we're going to insert rows and check the view. See where they end up. So we have 1 row in each partition, and those rows are within the expected range of data. What happens if we attempt to insert data before the expected range? So to 2011. It succeeds because we have a place to put that data because we were smart. So that row went into this partition, which is basically the F other, which catches anything below our first boundary point. What happens if we insert data that is that 25th January 1st? Well, we have a file group for 2015, but we do not have a file associated with that file group. So the insert fails. It's kind of harsh. But this is a way to prevent inserts from going into your last file, your last partition. Maybe you want to be harsh like that. Maybe you don't. So there's more to this. We don't have to get into all that. Let's do this. Let's see. Well, first of all, does anybody have any questions about what we've done so far? All right, I'm going to insert data, a lot of data. So see what the function looks like. So you have 1,001 rows in the expected range for each partition. We happen to have that 1 row from before. Now I want to show you what switch out, the difference between switching out. We have this staging table already, so I'm not going to create that again. Actually, I think I'm just going to truncate this table. I believe there is data in there. Oh, okay, good, gone. So we're going to create the partitioning staging table, which matches the schema exactly. It's partitioned exactly the same on the same partition scheme. And now I'm going to back up the database and the log to disk equal null just to kind of clear things out. Because what we want to do is count the number of log records before and after switching out. So if I'm going to do this again, log, okay. I want to see how many transaction log records we're starting with. I think it's usually about 12. All right, so I'll back up again. Okay, just want to get the minimum. 12, yeah? So what we're going to do here is begin a transaction, show the number of records in the log. We're going to count how many rows we have in these given partitions, and then we're going to run a delete. And then we're going to see how many transactional log records we have from a delete, not anything to do with partitioning. So, and then we're going to roll back. So you see we have a lot of records. Yeah. Action delete, transaction log records 1,033. Well, we deleted a bunch of records from one of the partitions. And this shows you what's in the log. There's 1,033 records. It's all this logging just for deleting 1,000 records. We're going to roll it back. Now we're going to do the same thing with switch. So we're going to clean out the log till it says 1 page. And we're going to see how many log records we have to start. It's 13. Okay. So we're going to begin a transaction. I'm going to declare a variable, like I said before, which is give me the partition number for this boundary point, because I'm going to use that to switch. I don't want to switch based on hard-coded values. I want to switch based on what I determine to be the correct partition number based on a value of, in this case, a hard-coded, but it could be a value that's passed. And then we're going to truncate the table. Then we're going to show how many transaction log records we have. And then we'll roll back. So we had 13 transactional records to start. After the truncate, we have 43 records. 43 versus 1,033. So you can see why people are interested in partitioning. Table partitioning as a feature. It can save tons of logging and time. And I think, yeah, just to go over the use cases, ETL load is a classic example of a great use case for partitioning. Purging data, switching out and getting rid of data. So those two are very common. Backup restore at the file group level. You can't do that unless you spread data amongst multiple file groups, which probably you want to do with partitioning. You probably don't want all your years of data if you just need to restore the most recent file group. Lock escalation we talked about, that's a maybe. If you were to back up and restore, you'd have to, as I said, spread your data around different hot and cold file groups. You could even make the file groups read only, the old ones. And there's ways of using the backup command to say, only give me the read-write file groups. You have to be careful with this stuff because you need enough transaction log to make it all work. But this is one way you could break data up. Query plans can regress. How tunable are your queries? Remember the example I gave before. I said if you're using entity framework, your queries are probably not too tunable. And you might need to reference this partition function to determine, okay, I have a value for a query. I can't change my query as I'd like to, but I can determine which partition that data value is in, and then I can say, okay, give me data that matches only this partition or between these partition numbers. So it's another way to kind of manually filter how much data you will read based on partition number. But if you're running entity framework or something like that, you probably can't do that. Best practice, bookend, empty partitions, verify split merge in non-prod. These are the people who I learned a lot about partitioning from. Kimberly Tripp, she's awesome. Dan Guzman is fantastic. Dmitry Korakovich is a guru. Kendra Little has more stuff out there on the kind of beginning or maybe middle realm of partitioning. This is what we covered today. These were our takeaways. This is my contact info, and that is my presentation. I'll stay on for any questions if people have any.
Ned, I got a question.
Sure.
If you wanted to create a sliding window, would it be easy enough to use that last switch that you had and just replace the date with a variable? Say,
Yeah.
for instance, I want to create a sliding window of a transaction table that has tens or hundreds of millions of rows, but 99% of the queries only reference the last 6 months worth of data.
Okay.
And I would like to have that sliding window change either on a daily or a weekly basis.
So is something going to change something else must be changing your queries then, yes?
Well, the queries would only be interested in whatever is in the last 6 months. So let's say I
Okay.
want quantities or something like that over that period of data. You know,
Okay.
these queries might reference how much data or how many records are in the last 3 months, but I'm giving
Okay.
6 months as a buffer.
Okay. So your queries will obviously have to use a predicate that references the partitioning column. And since that value changes over time, something will need to change your queries. It
Mhm.
could be that they reference, that they go against reference or metadata that you've defined, or that they base on the current date and just go back 3 months, but something will have to modify those queries just to be correct, to be
Yep.
clear. So
Understood.
let's say you have that, and so you don't have to worry about that part of it. Then you need a proc that does your maintenance that is either fired manually or an agent job. And that proc, Dan Guzman has a great blog post about this. That proc will need to roll off the older data and create a new boundary point in the currently empty partition on the upper partition that is supposedly having no data in it that is beyond the expected range. So that proc should do both of those, or maybe you split it up. But anyway, really easy. If you have your data laid out already, you have to have files and file groups to handle the data. Otherwise, you hit a roadblock. But let's say you had a proc that creates a file, creates a file group, adds a new file to the file group, rolls the data off, whether it's switch out and truncate or just truncate, and then splits and then it does a merge to remove the boundary point, and then it does a split to split the last empty partition on the right side, assuming we're talking range right, and boom, you're ready to go. And this is handled all the time. The problem people run into is when for some reason this stored procedure doesn't execute and they trusted that it was executing, and rows are going into that last partition, which should be empty beyond the expected range, and they don't discover it till there's hundreds and hundreds of millions of rows. So you need some kind of safety check to make sure that this maintenance proc is actually executing, but the actual logic in the proc is not complicated. Assume you have you've done your homework and everything is hunky-dory with storage and all that. So yeah, it's not at all rocket science. It's just you have to wrap your brain around what can happen. Now, Dan Guzman's blog talks about what to do if you're on a really busy system and you can't switch because you're getting blocked. So that's the real nitty-gritty stuff that is not a part of this presentation, but there are ways to do that, to just, let's say, switch at low priority or something like that, or to try and get an exclusive lock so that you can do the switch before you attempt to do it. So there's ways to do that. Long-winded answer, but there's ways to do it.
Okay.
I know it's a lot to kind of absorb in one session if partitioning is new to people. So people may be kind of like deer in the headlights. I would understand that. A lot of partitioning was not intuitive to me, and I really had to beat my head against the wall to make sure I understood what they were trying to say.